Hey everyone, and thanks for coming to our website on food additives. Join us for a sec as we go through a presentation about some of the most common food additives you see around today.
We're going to be talking about calcium carbonate, which is found naturally in limestone and is created from grinding limestone to form a very fine white powder that is odorless and has a somewhat sweet taste to it. In food production, it is used for either its hydrophilic applications by absorbing certain molecules, such as water molecules, or its hydrophobic applications by coating molecules that cause them to be water repellent. Calcium carbonate is a firming agent that has many applications as a food additive. It can be used as a whitening agent or filler for things such as paper, soap, mouthwash, lotions, or other powders. As a food additive, it can be used as another whitening agent, moisture stabilizer, calcium fortifier, and a firming agent. Obviously, it is a whitening agent because of the solid white color of the powder. Calcium carbonate helps to control moisture by absorbing water molecules in the air or space by surrounding the entire molecule to collect it into one place instead of being free floating. It is a calcium fortifier when added to food because you're directly adding calcium to the food. And it is a firming agent because it will interact with other gelling agents such as pectin to cause these molecules to precipitate into larger molecules and create a stronger structure for the food. This food additive is used in processing to help with inhibiting lumping in food production and aid in food transportation. Some other firming agents used, such as calcium chloride, are used for a taste enhancer of saltiness without an actual extra addition of sodium. Helps to improve the firmness of products such as fruits or vegetables, and it is a calcium fortifier. The same also goes for calcium citrate. It is widely used as a calcium supplement, and it's synthesized from fermentation where citric acid is created and calcium oxide is added to precipitate this salt for extraction. Calcium lactate is another calcium supplement that is widely used, and it is used also in food production for fruits, vegetables, jams, or even beer. Magnesium chloride is another one, and this is also used as a supplement, but it also is used as a coagulant in food, and also it can add some additional flavoring to food as well. These firming agents also have some safety concerns. A high intake of calcium can cause hypercalcemia, which can cause kidney stones, weaken bones, or interfere with certain hormones in your body. A high intake of magnesium can cause hypothyroidism, which can lead into Addison's disease or gastrointestinal disorders. To avoid this, we must make sure that when we add these firming agents, that we are only doing about 0.1 to 0.5% of the total ingredients.
Colors and color modifiers are food additives that are classified as final product additives that function as appearance control agents. They can be naturally found in many foods or synthetically produced in a lab. Although naturally occurring food colorants have been used for thousands of years, their synthetic versions have only been around since the 1800s. These first food colorants were originally used to hide defects in food and often contained hazardous or poisonous materials like lead, arsenic, and mercury. To protect consumers, the government decided that more regulation was needed, and in 1960 the U.S. added the Color Additive Amendment to the 1938 Food, Drug, and Cosmetic Act. This amendment gave further guidance and regulation on color additives by separating colorants into certified and colors exempt from certification. FD and C is commonly seen on food colorants and refers to the compounds acceptable products that it can be used in, F standing for food, D for drug, and C for cosmetic. Certified colors are the FDA's classification for synthetic additives that have been thoroughly tested in a lab and passed multiple government quality controls. Samples of each batch of product are sent to the FDA to be tested in a lab. The certified colors classification has been further separated into permanent and provisional certifications. Only 7 dyes have been given this permanent certification status. They are blue number 1, blue number 2, green number 3, red number 3, red number 40, yellow number 5, and yellow number 6. This permanent certification status means that they've been tested thoroughly and no lab has found that they contain any items that would be detrimental to consumer health. Provisional status is given when a colorant is awaiting lab investigation and will be considered usable pending these lab results. Although synthetic colorants have been vilified in recent years, there are multiple advantages to using synthetic dyes over the more natural alternatives. Their high tinctorial power means that less dye needs to be used to achieve the desired color, which lowers cost. Their high stability during processing and storage allows for greater shelf life and consistent color over time. Over natural colorants, synthetic dyes have a greater range of usability with water-soluble dyes and water-insoluble lakes. Synthetic dyes also produce a wider array of colors than from natural sources. The second FDA classification of color additives are colors exempt from certification. These additives are derived from natural sources or are synthetic compounds that are nature identical. Nature identical is a lab-created color additive that is biologically the same as the natural compound. This means that they are synthetic and are made in a lab, but their chemical structure is exactly the same as their natural variant. This classification includes color additives such as beet extract, turmeric, paprika, caramel, and annatto extract.
Now moving on to color control agents. Color control agents differ from color modifiers because they don't change the color of the product, but instead they are chemicals used to fix the product's natural color and keep it from degrading over time. The most common types of color control agents are nitrates and nitrites. These are used in salami, bacon, sausage, and other cured meats. The way it works is the nitrites will react with the meat and form nitric oxide. Then this will react with the heme compounds in the meat, forming nitrosomoglobin. This is the pink pigment in meat. As you can see on the picture on the left, when the nitrates aren't added, the meat turns brown and looks unappealing. Otherwise, when nitrates are added, the meat retains its pink colors. Nitrates are also antimicrobial and they function best around 5 to 5.5 pH. This is very important in cured and canned meats, protecting it from Clostridia bacteria. They can flourish in that pH range. This also makes the meat more appealing. Most people at a supermarket would not buy the brown meat on the left, even though it's relatively the same quality. But humans are built for visual appealing products. That's why the pink meat on the right looks more natural and will also sell better. There's also a concern with using nitrates as they can turn into nitrosamines, which can be harmful to the human health. Typically, they're not in cured meats, but nitrosamines can form under intense heat. Now I'm going to be moving on to freezing and cooling agents. The two most common freezing and cooling agents are carbon dioxide, mostly known as dry ice, or liquid nitrogen. Carbon dioxide and liquid nitrogen have both been approved by the FDA for use in the food retail business as long as the chemicals are not directly ingested in large quantities. These chemicals are extremely cold, usually less than negative 78 degrees Celsius. And on the slide, the machine depicted is a tonneau freezer. During the process of food products which to be cooled or frozen, liquid carbon dioxide can be sprayed onto these food products in the tonneau freezer. Since these products are at such low temperature and the products themselves are at a high temperature, the freezing carbon dioxide will pull the heat away from the food product and sublimate into a gaseous state. This gives that smoky effect everyone knows from dry ice and liquid nitrogen. The smoky effect can also be used for visual references in drinks or other food products to give it an appealing visual appearance. Now, there are some safety concerns while using the frozen carbon dioxide and liquid nitrogen since they are at such low temperatures. The FDA does not prohibit the use of liquid nitrogen or dry ice in the preparation of food products meant for retail or immediate consumption. Although the use of liquid nitrogen and dry ice can be harmful if ingested in large quantities due to their low temperature. If you swallow a whole chunk of dry ice, it can freeze burn the inside of your throat as well as other internal organs. Even the smoke coming off the products is known to cause irritations if inhaled, especially with those people with asthma. So it is always important to use gloves and handle liquid nitrogen and dry ice with care. And now we are going to move on to non-nutritive sweeteners as a food additive.
What are non-nutritive sweeteners? According to the 5th edition of Fenim's Food Chemistry, non-nutritive sweeteners encompass a broad group of substances that evoke a sweet taste or enhance the perception of sweet taste. These sweet-tasting substances can be synthetically synthesized or derived from natural sources and are designated as non-nutritive because they provide little to no calories when ingested by humans. Cyclamates were the first commercial non-nutritive sweeteners and were discovered in 1937. Cyclamates are synthetic sweet-tasting molecules which are derived from cyclohexylamines and cyclamic acid, and they are about 30 times sweeter than sucrose when compared by weight. Non-nutritive sweeteners are many times sweeter than sucrose, or table sugar, and for this reason they are also categorized as intensely sweet molecules. Non-nutritive sweeteners are added to foods to enhance the flavor or texture of the food without increasing the amount of calories. There are many types of non-nutritive sweeteners, and some are more stable than others. They can be added to either foods, such as ice cream and desserts, or beverages, such as diet sodas and low-calorie fruit juice. Non-nutritive sweeteners have been widely used for their ability to sweeten food without the added calories. However, there have been safety concerns and extensive research has been conducted to evaluate their safety. Cyclamate was banned as a food additive by the FDA in 1969 because it was discovered to cause bladder cancer in lab rodents, and the FDA prohibits the commercial use of any chemical that causes cancer in lab animals. Saccharin, which is another cyclamate, was also banned in 1977 because of its low incidence of causing cancer in lab animals. However, many scientists argue that animal data is relevant to humans, as humans consume much less of the substances and rapidly absorb and excrete them.
Here's a quick chart just depicting the different sweetness levels of different non-nutritive sweeteners. In summary, we went over today about firming agents, color modifiers, color control agents, freezing agents, and non-nutritive sweeteners. Thanks for tuning in on our website, and feel free to look around and hopefully you learned something new.